we will be solving today the question from Leetcode, that is 1514, path with maximum probability. Let's first understand what the question is telling. You are given an undirected weighted graph of n nodes represented by an edge list where edges of I, A, comma B is an undirected edge connecting the nodes A and B with a probability of success of traversing that edge. Suck prop. Given two nodes start and end, find the path with the maximum probability of success to go from start to end and returns it success probability. If there is no path from start to end, return 0. Your answer will be accepted if it differs from the correct answer by at most 25. Okay. So now for first let's understand what the question is telling. So here it is an example. You have been given undirected graph. Okay. Now you will also be given two nodes start and end. Okay. Now that start and end, you need to find it from start. Here it is 0, and you go to your end node, and you have to say what is its maximum success probability. So here in this case, there I can see two paths, right? Here is the path from 0 to 2 directly, right? And another path that I'm saying is that from 0 to 1 and from 1 to 2. Okay. Okay. Now see, it is a basic probability theory that probability is multiplied, right? So P of, if you could say 0 to 2, if I have to say, can be like, okay, so if it depends on the path, so you could say P of 0 to 1, right? Because you can go into that into P of 1 to 2, right? It is one probability also, okay? Or the max of, directly we have the probability of 0 to 2. So here in this case, if you can see why its answer is 0.25, it is because this 0.5 is multiplied with 0.5, okay? It is why now 1 by 2 is 1 by 4. So it is because that thing, right? Now here we do not need to find path, we can find it, we have to just find probability. Now see, can you relate something with Dijkstra, right? What the Dijkstra was telling is that Dijkstra is saying that you have been given a source node, that is let's take, you have any type of graph, right? Mm, and let's say this is graph and you've been given edges, right? 1 2 5 7 6 and 7, right? Now the Dijkstra is, let's say this is your source node. Now from this node you can find that what is the minimum distance from this source node to other node, right? And you use this weights, edges of weights as sum, and you find the minimum, right? Here the question is slightly changed. You need to find what? Maximum. You need to find what? Maximum. Now understand one thing, the minimum and maximum are both are similar type of functions. You can say they are monotonic functions. So the same thing we are implementing in Dijkstra, we can also implement it in it via this. The difference is that in the minimum place, you have to use max. And another difference was that the weights were added here, right? Weights were added. So instead, we can use the thing like weights are multiplied to get our resultant answer. So in Dijkstra, there are we can implement a Dijkstra algorithm via two ways. Okay, so one is using a priority queue, and another is set way, right? So I will be using a priority QA, and my priority queue will have the pair. It will be a pair, and it is a max heap. It is a max heap. Okay, max heap. Why max heap? Because we need maximum always. We need a maximum above. In Dijkstra, normal Dijkstra, we are using min heap. Okay, so just according to the question, you can just change the min heap to max and then inner functions. Okay, and this is our starting probability of reaching off from 0. We will take the source node as start node. This is in our case, this is the source node, this is the end node, and this is now. And initially in Dijkstra, the distance array look like distance array should be like infinite, okay, 1e9 and all that stuff, right? Instead we are just making 0 probability. It is same thing, it is similar thing, you can think like that, okay? And in this is our priority queue max heap, right? Our priority queue max heap, right? And it is storing what? It is storing probability comma node, okay? So initially, so let's start doing something dry run so that we could understand much better. This is max heap, okay? Okay, so initially we know that our probability of like 0 to 0, like 0 to 0 is 1, right? You can reach it from that. Okay, so we will update this with 1. Okay, we will update this with 1. Now next thing, we will push it into our priority queue. So the probability is 1 and node is 0, right? Okay, now we, as is in our Dijkstra, we come to top as it is the only element. This is only our element. Now we traverse through adjacent nodes of 0. We traverse through adjacent nodes of 0. The 0 has adjacent nodes of 1 and 2, right? So we update its probability. We see that okay, is 0 is we the probability is here 1. Okay, so we see that 1 into the edge weight, that is 0 to 1 edge weight, is 0.5. 1 into 0.5, is it greater than already the probability array? Is it greater? If we check that, okay, so it is greater than p of 1. Let's take p of 1. 0 to 1 is p of 1. Yes, it is greater than that. Okay, so update it with 0.5. Okay, and now again in adjacent node we check one more thing. 1 into zero point 0.5, 1 into zero point 0.2, sorry, it's 1 into zero point 0.2. This edge we are checking 0 to 2 edge, right? 0 to 2 edge, is it greater than 0? Yes, it is greater than 0, so do it 0 point 0.2. Okay, and now as we have updated them, these two things, we will push it into, first we pop this out, and then we push this to edge, like, sorry, we push this one, that probability is zero point 0.5 of this one node, right? Probability of zero point 0.5, probability is zero point 0.5 with node 1. Okay, and another is probability is like 0.2, 0.2 with node 2. Okay, right? Now which is higher probability? That is zero point 0.5, right? Zero point 0.5 is higher probability, so this will come first. Now we see we have node is our 1 and our node is 1. Okay, and now the p is zero point 0.5. Okay, probability it is. Okay, now we see its adjacent nodes. We see that 1 to 2 and here is 1 to 0. So we check that, okay, is my zero point 0.5 into what? Into zero point 0.5 that we are taking this edge, zero point 0.5, is it greater than its adjacent node, that is 0? So p of 0 is what? 1? No, it's not, so we do not change it, right? Next we check this adjacent part, this 1 to 2 edge. Okay, so we check zero point 0.5 into zero point 0.5, is it greater than 0.2? Yes, it's greater than. So we update it. We update it to 0.25, and we push again what? 0.25 comma 2, right? Simple. And we then pop this back. Okay, we pop this back. Now we, the maximum is this. So we take this. We again check 2 to 0, 0.2 into 0.25. No, it is not larger. We again check 0.25 into 0.5. No, it is not greater than. So there is no update. We pop it. Now this is the last element. See, there is a slight optimization in Dijkstra also. If your current probability of that node is already less than this point, this in this array, we need not check this its edges, its adjacent nodes. It's waste of time. We will see it in the code. What is this? What is the optimization is, right? Now let's understand the more examples that are in the okay. So this is our example two. Example two, the same example. The main thing is that if we take this path, this was 0.25 and this is the path 0.3. So its answer is 0.3. Okay, simple. And here we can't reach to because we in array here I show you initially the array was 0 0 0, right? Yes, so as there is no adjacent node, we would not be updating that and it will remain 0 only, right? It will remain 0. At the end we would be just returning the in this array the index of this 2, right? So we will just return this element that is 0, right? So let's get to the code and understand how everything is working. Okay, so first we will creating the graph to adjacency list. Okay, and so okay, so we have to be in graph. We will be having the list in which the elements of the list are pairs. It is int comma double the weight. Okay, so it is like that, pair of int comma double. Okay, and it's PD now. Okay, now we would traverse through edges and we would just insert like that edges of I comma 0 dot pushback edges of I comma 1 comma the sp of I. just change it this small sp so that we don't have to write much more code. Okay, so similar thing, that is of I of 1. Okay, now we have created our graph. Let's take this is start and end nodes, en and sn. Okay, and then okay, so now just go further. Okay, okay. We will be using Dijkstra. We will be having a priority queue, right? That is maxi, and this is the syntax, and we have element as what? The first is double part, right? Because double comma int. Because the first is not it is what I said here. I said here it is what probability comma node, because now the probability which is larger will be our top element. We did not have the node value higher. Okay, and initially we will be pushing. Okay, so first let's create our probability array, or we could say answer array, right? And that is having size n and 0. Now it is already initialized with 0 part here, right? And ans of our s node is always 1. You can reach okay. And our sorry answer array is of double, right? Okay, and okay, so now we will push pq dot push will push what? Probability, that is 1, and we could say ans of s and comma s. Now let's go through the Dijkstra code. It is like, while it's not empty, and then we would be returning our e index node, right? The eth index of ans array, right? Now see, what is our p? P is our pq dot top dot first, right? What is our node? pq dot top dot second. Okay, now what we're doing, we will be traversing through its edges, right? Edge of node. Okay, and we would just see that okay, if our ans of it, okay, what is it? Adjacent weight. So int adw, adjacent weight is it of it dot first, and in ad node is it dot second. Okay, sorry, it is node is first. Okay, here we have inserted like node is first, so this is it's a node is first, and the weight is it dot second, right? Now we would just check if our sorry, it should be double, weight should be okay. We would just check if ans of adjacent node is less than the adw into what, into ans of sorry uh into p, right? P, or we could say ans of node, it is the same thing. Ans of node, it will be most updated. Okay, so if we see that, just do ans of ad node is equal to adw into ans of node, simple, and we would just push that into our answer. So it's ans of ad node comma ad node, right? Yes, now the question is done, and okay, yes, mostly question is done. Let's run and check it. Is it working or not? Okay, so it was sn. I have okay, so we'll let it be s and e. Okay, okay, so we forgot to pop this element. My mistake. Okay, and let's submit and check, is it correctly working? Okay, it is getting accepted. Now I will show you slide optimization that we could use. See, this part that is traversing through adjacent node is only good, is only valuable if you have your node is mostly updated, right? So if the ans of node is like greater than p, instead p was sometime very old which was not used, so we would not call this. See, I will explain with the example here. See, this both things 0.25 and 0.2. Let's first see, this was a 0.25, okay, a comma 2, and this was a 0.2 comma 2. There were two nodes, okay, because this was maximum, you updated. Now your ans2 is having this 0.25. There is now, after popping this out, this will be your last element. There is no sense in doing this 0.2 and then checking with 0.2 into 0.2, and here also 0.2 into 0.5, because the much better that is 0.25 is already checked, so that there is no sense in checking this again. So if in the array of that ans node is already greater than this p, we would not check and we would do continue. So this is slight optimization, and maybe you sometime games time limit exceeded if you okay. So wait a minute, it is showing error. The issue was here, like the issue was here int the p is like int, so this p is not getting double, it is getting truncated, or it's getting converted to wrong value or snap value. That's why we do it for du- double, we make it double so that we can get our right answer. Okay, so let's run and check, and yes, it is fucking fine. And now if you have any doubts, you can ask it in the comments section. Thank you.